Okay, this is Mr. Weideman, and I'm here to help you with problem number 73 on your homework, page 114. This is another free fall motion problem. As soon as it's released from the helicopter, it is in free fall. So I know what its acceleration is. It'll be g, negative 9.81 meters per second squared downward. Now, what makes this problem unique is when the bag is dropped from the helicopter, its initial velocity is not zero. It says the helicopter is rising at 5 meters per second. That means that whatever is inside the helicopter, including the bag, is also rising at 5 meters per second. So when I release the bag from the helicopter, it's moving at 5 meters per second. And just like some of the problems we've done in this homework set, what's going to happen is it's going to decrease to 0, turn around, and drop to some v final after 2.0 seconds. I don't know exactly where that is, but 5 meters per second, well, it's going to slow down and it's going to stop in about a half a second. Then it's going to turn around and drop. So this diagram ought to be pretty accurate. My V final, after 2 seconds, that package is going to be somewhere below the release point. Okay? I have enough information where I can go to my kinematics equation and calculate distance. Now, this equation is pretty smart. If I plug in the right variables, given the right directions, I'm going to come up with the correct answer. Now, when I do this, I'm probably going to come up with a negative distance. But that's okay. That means that after 2 seconds that the bag is below the release point. Everything in kinematics is always in relation to where the story started. Okay, so now then that we have the object, it's dropped from the helicopter, so it is going to be more than likely below the release point, and it has dropped some distance that we previously calculated. In the meantime, while the bag was dropping, the helicopter was rising. So the total separation of these distances is the drop of the bag plus the rise of the helicopter. So I need to find the distance that the helicopter rose during this 2 seconds. Well, that's going to be pretty easy because the helicopter was rising at a constant velocity for 2 seconds for a total of 10 meters. So what I have to do to get this total separation distance between the two, I need to take the rise of the helicopter, which is 10 meters, and add it to the distance that the bag dropped that I previously calculated. Add the two together, and then I've got the total separation between the two objects.